In this video, we're going to be using Gaussian elimination to solve the system of equations that you can see here. So it starts with converting the system of equations into an augmented matrix. Now that we have the system of equations in an augmented matrix, we can start using elementary row operations to turn this augmented matrix into row echelon form. So what we're going to do is try to create zeros below that leading one right here. So this 2 and this 3, those need to become 0. So the operations we choose are going to help us achieve that. So how we write it, row 2. In order to make this 2 become a 0, we need to subtract 2 times row 1 from row 2, because that will give us minus 2 plus 2, which will be a 0 that we want. So it's going to be negative 2 times row 1 plus row 2. Similarly, from row 3, we want to make that term there 0. So what we're going to do is do negative 3 times row 1 from row 3. Row 1 is going to stay the same because we're not using any operations that is going to change it. And now we do the calculation. Minus 2 times row 1, so we're going to have minus 2 plus 2 is 0 as we designed it. Minus 2 times 2 is minus 4, plus 1 is minus 3. Minus 2 times minus 3 is 6. 6 minus 4 is 2. And minus 2 times 13 is minus 26. Plus 13 is minus 13. Next, we're going to work on row 3. Minus 3 times row 1, so minus 3 plus 3 is 0. Minus 3 times 2 is minus 6. Minus 2 is minus 8. Minus 3 times minus 3 is 9. 9 plus 1 is 10. And minus 3 times 13 is minus 39. Minus 39 minus 5 is minus 44. Okay, so that's the first step along our process to solve this, to get it to row echelon form. Next, one thing I notice is that the final row here, row 3, that's all divisible by 2, and that's one of our row operations. We're allowed to multiply rows by a non-zero constant. So dividing by 2 is like multiplying by a half. So let's just do that to reduce those numbers to make this thing a little bit easier to work with. So this time we're just going to work on row 3 and multiply it by, let's multiply it by negative 1 over 2 so that we can get the first coefficient to be positive. Rows 1 and 2 are going to stay the same, so I'm just going to fill those in. And row 3, so minus 1 over 2 times row 3, minus a half times 0 is still 0, minus a half times minus 8 is going to be positive 4, minus a half times 10 is going to be minus 5, and minus a half times minus 44 is going to be 22. Okay. Now remember what we need here. What we want is to have a 1 in this position here in row 2, right in the middle. Looking at my matrix right now, one option would be to divide across by negative 3, and that would give me a positive 1 here, which I want. But if I divided across by negative 3, that would create these awkward fractions here. And for the rest of the question, I would be dealing with adding multiples of fractions, which I don't really want to do. What I notice is that there's something else that I can do that will get me a 1 here with an elementary row operation that I'm allowed to use. So what would work is if I added row 3 onto row 2, I would have a 4 added to negative 3. That would give me a positive 1 and it wouldn't create any fractions. So that's the next step that I'm going to take. I'm going to take row 2 and add row 3 to it. Row 1 is going to stay the same. Row 3 is going to stay the same. But row 2, that one has row 3 added to it. So adding 0 to 0 is still just going to be 0. 4 and 3 is 1. Minus 5 and 2 is minus 3. And 22 minus 13 is 9. That took me too long. Okay, so I have the 1 in this position, and the next thing that I want to do is get a 0 below for row echelon form. So my next step is going to be to take row 3 and do -4 times row 2 plus row 3. Rows 1 and 2 are going to stay the same, so I'm just going to write those two in. And now we get to the part where we add -4 row 2 plus row 3. Again, this is going to be 0. -4 plus 4 is 0. -4 times -3 is 12. 12 minus 5 is 7. And -4 times 9 is -36. -36 plus 22 is -14. So this is working out nicely. You'll notice that in the final row, for row echelon form, we need a 1 in this position. So what we'll do is just multiply across by 1/7 on that last row. So that is, we're going to take row 3, multiply by 1/7. Rows 1 and 2 again stay the same. And the final row is multiplied by 1/7, so we get 0, 0, 1, -2. Okay, we're almost there. What we're going to do now that we have it in row echelon form is take it back out of the augmented matrix into equations. So in equations, what this looks like is x plus 2y minus 3z equals 13, y minus 3z equals 9, and z equals -2. So we've already got one of our solutions. We already have that z equals -2. So we're going to take this solution for z, sub it into the previous equation. Y minus 3, our solution for z was -2 equals 9. -3 times -2 is +6. If we bring +6 across, it becomes -6. 9 minus 6 is 3. So y equals 3 is our solution for this. And now we're going to put those values of y and z into the first equation. Two times 3 is 6. -3 times -2 is also 6. So, adding these up, 6 and 6 is 12. Bring the 12 across, it becomes -12, and 13 minus 12 is 1. So we have our three solutions. X equals 1, y equals 3, and z equals -2. And those are the solutions to the system of equations. You can always check by just subbing each of those values into each equation and making sure that they work. So if you plug in, for example, if you plug in 1, 3, and -2 in here for x, y, and z, 1 plus 2 times 3 is 7, -3 times -2, that's +6, 1 plus 7 plus 6 is 13, so it works in the first equation. Likewise, this should work in all of the equations, so you can always check your answers by doing that, and that is Gaussian elimination.